So in the previous lessons that we've been looking at, we looked at P's and Q's, which are the horizontal shifts or horizontal translations, and the vertical shifts, vertical translations. We're going to look at now A and K. And notice how it's written of the function. A is outside and K is actually inside of that function notation. And you'll see it when it makes more sense when we're talking about the base functions or any other functions. We're going to kind of break this up into kind of small components. We'll first talk and define what A and K are in terms of their vertical stretch and compressions, and then we'll actually look at what actually happens to those functions. For A, it is a vertical stretch and compression. A lot of you actually understand that. It's directly related. A actually affects the Y component directly. Now, when I say directly, it means multiplication. So, for example, by definition, when A is greater than 1, this actually responds in English a vertical stretch by a factor of A. It's directly related. It's vertically stretched. In your handout or the PDF or in the PowerPoint, it might use the word elongated. I don't like using elongated. Just stretch is easier. Just a stretch. Notice a vertical compression is when A is in between 0 and 1. What does that mean? A fraction or a decimal, like a half or 0.333. That would be a vertical compression by a factor of A. So notice it's directly related. And that's what a lot of you, again, and I notice you see it on the top in orange maybe you can't see it at home, if you zoom in. That's what you kind of learned in grade 10, the vertex. So it makes perfect sense. Here's where K gets a little weird. When we talk about horizontal stretches and compressions, it's going to be the reverse. When K is actually greater than 1, and you'll see in a moment, it's not directly related. So notice what I've used. This is the standard. Usually a lot of you find out. When K is greater than 1, it represents a horizontal compression by a factor of 1 over K. And you'll see it more explicit when we actually give you an example. So this is weird. When this number is a large number, larger than 1, let's say 2 or 4 or 5, let's say 2. When K is 2 of the function, it actually means it's a horizontal compression by a factor of 1/2. It's inversely related. So it's not direct, inversely. Similarly, when K is in between 1 and 0, like a decimal, like a fraction, this actually means a horizontal stretch by a factor of 1 over K. So for example, if the K value was 1/3, it's actually a horizontal stretch by a factor of 3. So that's what's kind of weird. K is inversely related. Let's go with some specific examples. And you see them there. So I'll just reproduce them. If I were to ask you to translate what this is, first of all, it's kind of silly, but I play this game with my students. Is this an A, a K, a P, or a Q? Well, a lot of sense, Mr. Chen, this is an A because it's incorrect. And so in English, this is actually a vertical stretch by a factor of 2. That's what that means. Let's get another example here. We'll go with the third one really quickly. It says y is equal to f at 4x. And again, the 4, that's not an A. It's not a P, it's not a Q, it's a K. It's a K. And what would you say in English? What kind of transformation is this? Well, you would say this is a horizontal compression by a factor of 1/4. So it's inversely related. So what I'm trying to show you, ladies and gentlemen, before we do the mapping rule or mapping technique, I'm trying to give you the descriptors of how you're supposed to interpret the function. Let me give you a specific one that might be easier for a lot of you. Let's put this above. Y is equal to 2x squared. And maybe for this one, y is equal to root 4x. So for the base parabola, that would be y equals x squared. And in it would be vertically stretched. Now I'm gonna exaggerate it maybe. That's maybe what that is. Because it got skinny, vertically stretched. This one, however, although I know it's a 4, it's a root function. So that's y equals root x. Horizontal compression, so it's gonna get skinnier, skinnier, skinnier. So we're just doing the sketching. It's gonna look something like this. It's gonna be smaller. It's still gonna look the same, but it's gonna be horizontally compressed. That's why some students find this difficult, because even though this number is greater than 1, it's the flip.